In this example, we're asked to find the determinant of a 4x4 matrix. Now, we don't have values for A, B, C, and D, so our final answer is going to be in terms of A, B, C, and D. The idea here is to use row operations to write a triangular matrix based on this one, and keep track of any changes to the determinant so that we have something that's equal to the determinant that we're given here. So the first thing I would do, I would be headed towards the row echelon form of this matrix. So I would aim for getting a 0 here, so I would do negative row 1 plus row 2. I would aim to get a 0 here, so I could do that by just doing row 1 plus row 3. And I would aim to get a 0 here, so I'm going to do negative 2 times row 1 plus row 4. So each of these row operations, none of them change the value of the determinant. So the determinant that we're given will be equal to the determinant of the new matrix once we perform those row operations. So the first row is going to be unchanged, A, B, C, D. Fix that just a little bit there. Okay, let's see. So negative row 1 plus row 2. So negative A plus A, negative B plus B, negative C plus negative 3C, so that's negative 4C here. Negative D plus 2D gives us 1D here. Okay, in row 3, we're doing row 1 plus row 3. So A plus negative A, B plus negative B, C plus negative C, gives me 0. And D plus 3D, so that's 4D. Okay, last row operation, negative 2 row 1 plus row 4. So negative 2A plus 2A is 0. Negative 2B plus B, so this is negative B. Negative 2C plus negative C, so that's negative 3C. And negative 2D plus D, so that's negative D. Oops, that's a D. Okay, and those determinants would be equal. Now, if I rearrange this a bit, I'll have a triangular matrix. So I'd like to move this row up here. So I'll start by swapping rows 2 and 4. Now, when you swap rows of a matrix, let me write this down, that changes the sign of the determinant. So when I do this row operation, this will be equal to the negative of the determinant of the row operation where I have that swap. Every time you swap rows, that changes the sign of your matrix. So row 2 is going to move down here to row 4. Row 4 is going to move up here to row 2. Negative 3C, negative D. And row 3 staying the way it is. 4D. Oops, sorry, that's a little hard to read there. Now, if I swap now row 3 and row 4, so if I do another swap, then I'll have a triangular matrix. So that's going to be my next transformation, or my next row operation, I should say. Swap row 3 and row 4. That, again, will change the sign of the determinant. So now this is equal to, I change the sign again. So it's going to be negative 1 times that negative 1 that we already had out front times this negative here. So now it's just a positive. I mean, those two swaps both change the sign of the determinant, so we're back to the original, or the original sign. Okay, and so our matrix now, I have negative b. It turns out that these next entries aren't really going to matter, but I'll write them down just for completeness here. So negative 3c and negative d, I think that is. Swap the last two rows. So now this will be 0, 0, negative 4c, and d. And the last one will be the 0, 0, 0, 4d. So we now have a triangular matrix. And we had a theorem in section 3.1, at the very end, that said that for a triangular matrix, the determinant is equal to the product of these entries along the main diagonal. So the determinant of, or that original determinant, is equal to a times negative b times negative 4c times 4d. And so I've got the two negatives, that'll make a positive 4 times 4, 16, times a times b times c times d. And this is the best we can do without knowing the values of a, b, c, and d, that the determinant of that matrix is equal to 16 a, b, c, d.